Hey bestie, it's Maggie back with Math Savvy. And today we are going to talk about when your teacher gives you a function, they give you a bunch of numbers, and then they're like, what does this graph look like? And you're like, if you haven't watched my video about limits at infinity, that's going to be super helpful. Let's just get right into it. Okay, so the first kind of discontinuity is called a hole. And a hole happens when something from the numerator and the denominator cancel out. So in this case, we have a hole, and the hole is going to be at x is equal to 1. So whatever makes this thing 0, x minus 1 is equal to 0, x equals 1. So we're going to say that there is a hole at x is equal to 1. The next type of discontinuity is called a vertical asymptote. A vertical asymptote happens wherever the denominator is 0. Granted, there's not already a hole that was canceled out. So like in this case, nothing cancels out. So we're good there. Now we look at the denominator. Okay, where is the denominator 0? Well, the denominator is 0 at x is equal to 1. So there is a vertical asymptote at x is equal to 1. A vertical asymptote looks like when you draw a vertical line down the graph and either side of the function cannot cross that line. It can't cross it. Also important to mention that your teachers are probably going to want you to write x equals 1 as a vertical asymptote. How are you going to remember x is equal to 1? Well, it crosses the x-axis here. So wherever it crosses the x-axis, that means x equals 1. Okay, cool. The next type of discontinuity is called a horizontal asymptote. A horizontal asymptote is what's going to happen at infinity. Wait, that did not make any sense. Bruh. So to find where the horizontal asymptote is, you need to take the limit as x is approaching infinity. If you don't know how to do that, I also have a video about how to do that. And it's going to tell you the horizontal asymptote. So in this case, we're just going to look at 2x over x. The x's cancel out. Your answer is going to be 2. So a horizontal asymptote is exactly what it sounds like. It's just a horizontal line where the function around it cannot cross that line. So here our horizontal asymptote is 2. Your teachers are probably going to want you to write horizontal asymptote at y is equal to 2, not x is equal to 2. How are you going to remember that? Well, the horizontal asymptote crosses the y-axis. So horizontal asymptote at y is equal to 2. Pop quiz, does this function have a vertical asymptote? Well, a vertical asymptote is when the denominator is 0. The denominator is 0 when x is equal to 0. So we have a vertical asymptote here, which makes sense because this function is not crossing that line. Period. Time to review. A hole is when something cancels out. A vertical asymptote is going to be x equals because it crosses the x line on the graph, and it happens wherever the denominator is 0. Forgot to mention that if something cancels out and there's a hole, there's not going to be a vertical asymptote at that hole. So like here, there'd be a hole at 0, and there would only be a vertical asymptote at -1. There would not be one. There would not be a vertical asymptote at 0. A horizontal asymptote is going to be y equals because it crosses the y-axis, and it's just going to be the function's limit when you take the limit as x approaches infinity. Let's put this into action now. So let's say your teacher gives you this function and they're like, okay, babe, what kind of discontinuities does this function have and where are they at? First things first, we can see that this x minus 1 is going to cancel out. So we know that there is going to be a hole at x is equal to 1. We can also observe that in the denominator is going to equal 0 when x is equal to -2. We know that there's going to be a vertical asymptote at x is equal to -2. As we take the limit as x approaches infinity, we're going to get 0. So we also know that there is going to be a horizontal asymptote at y is equal to 0. So another question that they love to ask on quizzes and tests is going to look something like this. And they're going to be like, which graph is this function? So what you have to look at is everything that you already said about what's happening with this function and kind of like process of elimination. So whole at 1, they both have a whole at 1, so that doesn't really help us much. Vertical asymptote at -2. This function has a horizontal asymptote at -2. What about this one? Uh-oh, this crosses the asymptote, which means it's not the function, because we know that our function has a vertical asymptote at x is equal to -2. But you might ask, Maggie, what's going on? How come it's this function and not this function right here? Because that would also work with a horizontal asymptote at 0 and a vertical asymptote at -2. That is such a good question, babe, and we are gonna get to it right now. So we're gonna address that question in this example here. So your teacher gives you this function, and they're like, same questions as before, except graph it this time. Your teachers are going to love to ask you questions where you're gonna have to factor what's going on in the function.
That is so true, bestie, especially in this unit. So when they give you stuff, make sure it is all completely factored. And if you're bad at factoring, something to look out for is if you see something like this x plus 1 in the denominator is probably going to be one of the things that factors in the numerator. So start with the denominator, and it's not going to be the case for every single one, but it's super common.
So factor this problem. Now it's a lot easier to see the kind of discontinuities that we have going on here. So immediately we notice that x plus 1 and x plus 1 are going to cancel out. What does that mean? It means that there is a whole at x is equal to -1. Easy. All right, next, let's address vertical asymptotes. This x plus 1 has already canceled out, but we're still left with this x minus 3 in the denominator, where this denominator is going to be 0 at 3. So we know that there is a vertical asymptote at x is equal to 3. Okay, last but not least, we are going to take the limit as x approaches infinity of this problem, and that answer is going to be 1. So we know there's a horizontal asymptote at y is equal to 1. But now, how are we supposed to know what this graph is going to look like? Great question. Okay, first things first, you've got to draw what you already know. So we know that there's a vertical asymptote at x is equal to 3, and there's a horizontal asymptote at y is equal to 1. And we know that there's a whole at x is equal to -1. But how do we know if the function looks like this, or if it looks like this, or if it looks like this? Well, we have to plug in some numbers. So what you're gonna do is you're gonna see where the vertical asymptote is, and then you're gonna plug in a number on the left side of it, something easy. So let's just pick 0, because that's the easiest. Then you plug 0 into the function and see what you get, because you're trying to say, okay, if we plug in a number on this side, is that number going to be above the horizontal line or below the horizontal line? So let's pick 0 because it's the easiest to work with. We pick 0 and we're going to plug it into this function. This is already canceled out, so it's going to be 0 minus 2 over 0 minus 3. Well, that's just -2 over -3, which is equal to 2/3. Where is 2/3 on this graph? Well, 2/3 is like probably what, right here, which is below the horizontal asymptote. So that means we know that on this side of the graph, it's going to be hanging out down here and not up here. Okay, we're almost done. We just have to do the same thing for the right side. So we have to plug in a number on the x-axis that's right over here. So let's just plug in 4 because that's pretty easy. All right, this is canceled out, right? So we can take this down here. 4 minus 2 over 4 minus 3. That's going to be equal to 2 over 1. All right, so that's equal to 2. Where's 2? Here. And it's above this line right here. So we know that on this side, the function's going to be hanging out above this line here. So we can tell that our graph is going to look something like this. And last but not least, don't you dare forget that there is a whole at x is equal to -1. So this is pretty much like the hardest example that your teachers are going to ask you. So if you feel good about this, you're going to be super solid on your quiz or test or whatever. If you need more help, I'm always available for tutoring at math-savvy.com. And don't forget that we're on a floating rock, and if you fail your math test, it really doesn't even matter that much.